Complete wiring of control systems and sub-assemblies can now be accomplished with greater productivity within your organization. The CC Matic from Vago provides complete and fully automated wiring when all components use Vago cage clamp terminals. The system is most efficient within switchgear cabinets and control systems where the percentage of wired connections with cross-sections up to 1.5 square millimeters is over 90%. Previously, wiring was performed manually. For each point-to-point connection, the process was as follows. Each wire was individually stripped, connected, and then labeled. Wiring with cage clamp technology, as shown here, results in a clear time saving compared with historical screw or soldered connections. The stripped and inserted wire is routed within the cable ducts to the second connection and cut to the correct length. It is then stripped and supplied with the correct wire label and inserted. Finished. Time to complete, approximately 40 seconds. Generally, the cage clamp connection technique does not require end sleeves for wires. However, they are quite often used, and this, of course, incurs additional time and expenditure. CC Matic, the world's first automated wiring robot for the cage clamp connections, takes about 6 to 8 seconds, dependent on the wire length, for point-to-point wiring with automatically dyed, labeled, and supersonically compressed wires. The input information for the CC Matic system is generated automatically from the DDSC, one of the world's leading electrical design solutions developed by CIM-Team. DDSC generates connection information from the schematic and panel diagram with wiring-specific restrictions and transfers it directly to the CC Matic controller. The basis for the automated wiring is the schematic diagram. In DDSC, parts and symbols are selected from the library and placed into the schematic diagram. Automatic checks are performed dynamically to ensure manufacturability. Examples of this include ensuring that duplicate use of a component element or incorrect terminal designations are not permitted. Electrical connections are then drawn, with the manufacturing relevant attributes added as required. Again, online checks ensure that faults, such as short circuits, are automatically avoided. Information from the schematic diagram is then used to generate the control panel layout and wiring. First, automatic and manual placement of parts onto the mounting plate is carried out. Automated checks necessary for the robotic wiring are performed automatically. These include a minimum distance check between components and cable ducts. An option for automatic placements of components onto standard mounts provides extremely rapid creation of the mounting back plate. The next stage is to automatically wire the components based on connection information in the schematic diagram, routing paths, and actual component positioning. Here again, the system performs the necessary manufacturing relevant checks during wiring. DDSC calculates the fill degree level within cable ducts and searches for the shortest connecting route for wires, while avoiding areas where routing is not permitted. With the information generated, DDSC then calculates the paths for the robot, calculates part placement information, and then transfers wire color and wire labeling information directly to the CC Matic. The user doesn't need any knowledge in programming, but the CAD system acts as an automated programming station for the CC Matic. The optical system integrated into the wiring head of the robot provides a comparison between nominal and actual placement. In other words, between CIM-Team's DDSC and CC Matic systems for providing error-free wiring. CC Matic is the revolution in automated circuit wiring, enabled by the use of Vago's cage clamp technology. The cage clamp is used in Vago's modular terminal blocks, PCB terminals, plug connectors, transformer terminals, and interface units, as well as in Siemens Sirius low-voltage controls. The next generation of automated electrical design for manufacturing, driven by DDSC, the system for electrical design and documentation, from CIM-Team.